Hey guys, today we were actually putting some of these logarithm functions on a graph. And to be able to do that, we have to first talk about what the logarithm function looks like. So all logarithm functions kind of look like this. They start here, and they get really close to this asymptote, and then they kind of start tapering off to the right. Now they're technically going to keep going up over time, but they're just going to keep going up slower and slower and slower and slower, but they go down really quickly. But they don't go to the left past their asymptote at all. All right, and so let's look at some points. These are kind of the base points for log base 2. So if we have base 2, if I plugged in 0, it would give me an error message because we can't take the log of 0, so we don't have a y-intercept. That's what causes that. Then, if I were to plug 1 in, okay, if I were to plug 1 in, we would get at 0 right there. And then if we plugged in 2, that's my base, we would get 1. So there's a couple of rules here. The main rule is if you ever plug in 0, we get an error starting off, and then our last one's going to be base and our 1. But we're always going to have a point, no matter what your base is, for your standard form, you're going to have 1 at 1, 0. Okay? Now, don't forget that we have an asymptote here. And an asymptote is a line a graph approaches but cannot touch. We cannot touch it. All right? Let's take a look at our next one. So we can use base 2. We can also use base 10. Same idea. The only real difference is that base 10 changes that number and it kind of goes out even quicker. Okay? And so it goes up slower. You kind of think about it that way. Let's talk about domain and range here a little bit. All logarithms kind of have a similar domain and range. Our domain is going to be just greater than your asymptote. Just whatever your asymptote is. And notice how I don't have a bracket here. We have parentheses. You're always just going to have a parentheses. It's just going to go from whatever your asymptote is all the way to the right. And then our range, even though this doesn't look like it, technically it's going to keep going up for forever. And so my range is, it goes down for forever, it goes up for forever, it's negative infinity to positive infinity. So for all of your logarithm problems, for every single one, your range is going to be all real numbers. All right, and our last one is e. So if I have a base of e, that's going to affect my graph. It's also going to affect my table here. My base here at the end, e is approximately 2.7. It's like pi, it goes on for forever, but yeah. E is approximately 2.7, and that's going to be my base if we have a natural log. Because remember, natural log has a little hidden invisible e right there. Okay, so now let's graph one of these for ourselves. What do you say? So let's start here. First thing we're going to do is list my a, my base, my h, and my k. All right. So my a for this one, there's nothing here. My a is just 1. My base is 2. My h, remember, it's going to be a liar, so my h is 3 and my k is 2. So once we have that information, it's honestly really helpful. Let's write our parent function. So our parent function is what our graph would look like if I did not have my a, h, and k. So that's just going to be y equals log base 2 of x. So our base still stays there as part of my parent function. Let's talk about my transformations. If I have my h is 3, that means we're going to go to the right 3. If k is 2, that means we're going to go up 2. And then that's all of our transformations. Okay? My vertical asymptote. Your vertical asymptote is going to be whatever h is. So let me write that out here. My vertical asymptote is x equals whatever h is. So in this case, x is going to equal 3. So that means that whenever I draw my vertical asymptote out here, we can just go over 3 and draw that vertical asymptote there. Okay? So I have this vertical asymptote straight up and down, so it kind of shows you where my graph is going to go. It's going to go out to the right of this vertical asymptote. Now, if it goes out to the right of the vertical asymptote, and my vertical asymptote is 3, that means that my domain is going to be x is everything greater than 3, or 3 to infinity. So that also tells me we already know that my range is going to be all real numbers, negative infinity to positive infinity. So it goes just like that. Then let's get some actual points on my graph. So if we look back, this is our parent table. And so we can kind of go, okay, we know I have a base of 2, and that's just going to be an error. So this is our new points that we can put on my graph. And so we're going to go x plus h. Now my h is 3, so for each one of these we're going to go x plus 3, and we're going to go a times y plus k to find my y's. So we're going to go y plus 2. All right, so let's take some of these points. So if I start with 0, 0 plus 3 is 3. Okay, now my next one, 1. 1 plus 3 is 4, and my base, which is 2, 2 plus 3 is 5. So those are my points on the left side. What about my points on the right side? Well, error is still just going to be error. That one doesn't change. What about 0? 0 plus 2 is 2, and 1 plus 2 is going to be 3. So now I have some points. I have a point at 4, 2, and a point at 5, 3. So let's put those up here. We're going to go over 4, up 2, and over 5, up 3. And now we can see where my graph is going to go. It's going to go up through this, and then it's going to go out to the right. All right. Now, don't have to be super specific, but I wanted to point something out. Yesterday we did all that work finding x and y intercepts. Now, this one obviously doesn't have a y-intercept, but it does have an x-intercept, and we could find that. In fact, on yesterday's homework, take a look at number 8 right here. It's the same exact problem, and we did not have a y-intercept, and my x-intercept was 3.25. So it actually works. Same thing, because look at this, look at our graph here. Look at our graph here. We have a x-intercept at about a little bit more than 3, 3.25. And so you can see how you could also use your x and y-intercepts to help you graph these. Okay? Remember, you can also use Desmos.com to help you see where your graph is going to be. All right. Now, so the page, let's take a look at number 5. So number 5, we're going to label my a, my h, my k, and my base. So my a is -2. My h is -1. Remember, it's the opposite of what's inside the parentheses. My k is -3. And my base, Mr. Martin, there is no base there. Remember, if we just have a log written without a base, that's going to be base 10. So we have a base of 10. So my parent function is just y equals log of x. And we can list out my transformation. So first transformation, for h, we're going to go to the left 1. For k, we're going to go down 3. For my a, that negative tells me that I'm going to have a vertical reflection. And since it's 2, we're going to have a vertical stretch by 2. So we got a lot going on. So all we're really doing is we're taking that 2 and we are just going to, we're going to be taking it and we're going to be multiplying all my numbers by 2 there. So my vertical asymptote, remember your vertical asymptote is what h equals. So that's going to be -1. So I'm going to have a vertical asymptote on this problem of -1. We can put that on here. Vertical asymptote at -1. So my graph is going to go out to the right of this. It's going to be out to the right. That negative, that vertical reflection, might make it look a little different. Okay, so our domain still is going to be the same. It's going to be x is greater than our vertical asymptote, so x is going to be greater than 0. I mean, sorry, not 0, -1. X is going to be greater than -1, or we can go -1 to infinity. All right, and my range is going to be all real numbers, -infinity to +infinity. Okay, then let's find some new points to put on my graph. My first point here, we're going to have x -1, because that's what my h is. So let's work these out. First off, 0 minus 1, -1. 1 minus 1, 0. My base, hold on. My base, what is my base? Oh, it's 10. Okay, so that number is 10. 10 minus 1, 9. So there's my x's. What about my y's? Let's take a look here. So we go a times y plus k. Okay, well my a is negative 2. So we're going to go negative 2 times each y plus my k, but my k is minus 3. So let's go one at a time. So first off, my error doesn't change. It's still going to be an error. What about 0? Well, let's see. Negative 2 times 0 minus 3. Negative 2 times 0 is going to go here. Negative 2 times 0 is 0. 0 minus 3 is negative 3. So I have a point on my graph at 0, negative 3. So right down there. Then, my next one here. We're going to go negative 2 times 1 minus 3. Well, negative 2 times 1 is negative 2. Negative 2 minus 3 is negative 5. Okay, so we're going to have a point at 9, negative 5. Oh man, that's way out there. All right, well let me show you. So let me kind of put a picture in your head. What we're doing is we're taking my graph. My graph kind of goes out like this normally. Okay, and what we're doing is we're going to the left 1, we're going down 3, and then we have a vertical reflection. And so we're going to reflect it like that, and it's going to stretch out. So that's what causes this stretch like this. And so if we're going down, we're stretching it out like this, what's going to happen next is we're going to need to just draw it out. It's going to approach my asymptote here. Oops, do that too shallow. It's going to approach this asymptote here. It's going to hit this guy, and then it's going to shoot out to the right. But notice how it's upside down, and that is because of my negative a. All right? Okay, here we go. Number 6. So number 6, same idea. List my a, h, and k. So my a is 1/2. My base is e, because we're using natural log. My h is going to be negative 2, and my k is 5. So my parent function is just y equals the natural log of x. Okay, so my transformations are going to be that we're going to go to the left 2, we're going to go up 5, and we're going to have a vertical, since this is a fraction, it's going to be a vertical compress by 1/2. So a vertical compress by 1/2. Okay? So think about our graph. We're not flipping it, but we're going to go to the left 2, we're going to go up 5, and we're going to have a vertical compress by 1/2. All right, my vertical asymptote, remember that's just x equals whatever my h is, and my h is negative 2. So we're going to have, we're going to have x equals whatever h is, and my h is negative 2. So we have x equals negative 2. We can put that asymptote on here. Have a little asymptote there at negative 2. My domain is it's going to be greater than that. It's always just greater than whatever your asymptote is. So it's just going to be x is greater than negative 2 or negative 2 to infinity. My range is going to be all real numbers, negative infinity to positive infinity. Now, we can put some new points on here, okay? In this case, my base is E, and we're just going to name that 2.7, okay? So E about 2.7, that's going to be my base. And so, let's see here, my H is 2, so for each one of my lefts, we're going to go x minus 2. So for 0, we're going to have a point at negative 2. That makes sense. That's where my asymptote is, so that creates the error. 1 is going to be 1 minus 2, that's going to be negative 1. And then 2.7 minus 2, we're just going to have a point at about 0.7. Doesn't need to be exact, kind of give us an idea though. All right, now for my y's. For each one of my y's, we're going to go 1/2 times that x plus 5. Okay? 1/2 times whatever my x is plus 5. So first one's error stays the same. What about 0? we can go 1/2 times 0 plus 5. So that's just going to be 0 plus 5 is 5. Perfect. Okay. What about that 1? Well, let's do that one. Let's go 1/2 times 1 plus 5. So we're going to have 0.5 plus 5 is 5.5. So here are some points to put on the graph. We're going to have 1 at -1, 5, -1, 5, and we're also going to have 1 at 0.7. So a little over halfway to 1 up to 5.5. So that's about right there. Like I said, it doesn't have to be perfect. Then we're just going to, it didn't flip, so we're just going to hug this asymptote, catch those 2 points, and go to the right. So hug this asymptote, catch those 2 points. That was not very well drawn. Let's try again. Hug this asymptote, catch those 2 points, and go on off to the right. Okay? So all of these things, great things to keep in mind. All right? Okay, let's take a look at this last little multiple choice question, little matching. So we have 4 graphs over here, A, B, C, and D. So log base 2 of x, normal. We're starting at the center. We're just going up regularly. My vertical asymptote is just at 0. So which one of these has a vertical asymptote at 0 and didn't shift at all? That's just going to be, and has a point at 1, 0. See how that has a point at 1, 0? Okay, so that's all we're going to do. This one's going to be C. What about this one? Log base 2 of x minus 2. That means that we're going to go to the left 2, right? So we're going to go out here to the left 2. Check it out. That means that my asymptote there is at -2. Hey, that one's obviously going to be this B one. So my B is going to be this one that got shifted to the left 2. This one's going to be one that went up 2, but still has an asymptote at 0. So we have this asymptote at 0. Check this out, how it shifted up 2. So this A is going to be the one that shifted up 2. And then lastly, x minus 2, that one's going to be the one that went to the right 2. And so that one's obviously going to be this one out here, which is D. All right, so that one is D. So keep all that in mind as you go through this. If you need any help with any of this graphing, please be sure to let me know. All right, we're almost at the end of the school year. Thanks, guys. Hope you have a great rest of your day.